My name's Django Armstrong. I'm from the University of Leeds, from the School of Computing in the Distributed Systems and Research Group. And at the moment, I'm working on an FP7 project called the ASCETiC project, which is looking at adapting services for adapting service life cycles towards energy efficient clouds. So the outline of the talk and the demonstration that I'm going to give you today is this. I'm going to introduce you to what the ASCETiC project is trying to achieve, a bit of background on the aim of the project and its scope. I'll also present you the ASCETiC architecture and toolbox that we've created in the first year of the project, and then I'll go on to present an overview of the software demonstration I'm going to give you, and an overview of the web application that we've used to illustrate our architecture. So a bit of background. The ASCETiC project's all about energy efficiency in distributed systems, and specifically in cloud computing. And energy efficiency at the moment is very much at the heart of the European Union's 2020 strategy for creating a smart, sustainable economy. And basically, energy efficiency is increasingly becoming important in the ICT industry as our energy consumption increases. So we've seen a dramatic increase in the use of cloud solutions and the associated data centers that come with those, and also the increases in energy costs. So to sort of tackle these energy-related issues, people are trying to come up with energy-efficient solutions to computing equipment and power management strategies. So this is a graph that I've taken from a Gartner report that basically projects the growth of cloud computing's electrical consumption into 2020. And we can see here that data centers and telecoms are only a fraction of what the projected total cloud consumption is going to be in 2020. So whereabouts is this energy being consumed within data centers? The data centers are usually comprised of tens or hundreds of thousands, if not millions, of hosts that are usually closely coupled and in close proximity. So you have businesses such as Amazon, YouTube, Google, all using these data centers for their businesses. And the majority of the power that these data centers use is in the actual servers and storage systems themselves. And then the next biggest energy consumer is the cooling that goes along to make sure that the servers don't overheat. So the data centers are using energy, but whereabouts are we trying to sort of tackle energy awareness and reduce that energy consumption within the data center? In this slide, there's a couple of examples of different strategies. So at the hardware level, people have invested a lot of money, Intel, for example, in dynamically scaling voltages and frequencies of CPUs, and the increasing emphasis on power-saving techniques in operating systems. Other avenues that people are exploring in energy-aware computing are in the network stack itself, especially now that we're moving towards a software-defined network paradigm, and also in the virtualization layer itself. So how can you make virtual machines and the hypervisors that run them energy efficient? To bring this into the context of the ASCETiC project, we're trying to tackle this energy problem across all layers of the cloud stack. So we're interested in trying to optimize the energy consumption of infrastructure, platforms and software that are deployed on cloud computing platforms, and not specifically limited to one lifecycle element. So traditionally a data center may be only interested in the service operation and the energy consumption. This project is trying to take a holistic approach to energy consumption and look at it from the application development right down to the hardware level, and how we can optimize each aspect of an application's development and service lifecycle to reduce energy. So the solution that the ASCETiC project has come up with in the first year of the project is a reference architecture that you can see on the right-hand side that comprises of a number of tools that a developer or a platform, an infrastructure provider can use to gain an understanding of the energy consumption of their specific services. So the idea here is that we want to integrate energy efficiency into the service construction, development and operation, leading to what we hope is an energy efficient embedded software lifecycle. And we are achieving this by implementing the tools within our architecture. One of the key benefits that we see of our architecture is that we don't only want to present people with an understanding of the energy consumption of their distributed systems in cloud computing platforms, etc., but we also want to enable our architecture and tools to be able to adapt the systems automatically. And we have this idea that in year 2 and year 3 of the project, we're going to explore how we can enable self-optimization and self-adaptiveness within each of the layers. And then in the 3rd year, how we can adapt each of these layers to reduce the total energy consumption altogether. So the software demonstration and the reason that I've come here today that I'm going to present to you, the goal of it is to demonstrate the energy awareness within the ASCETiC architecture from a generic use case perspective. So the ASCETiC architecture is looking at 2 specific use cases, one computationally expensive and one data expensive. The idea is, with this demonstration is that I'm going to illustrate the use of the architecture from the platform layer down. And so the emphasis of the demo is more on the infrastructure of a service layer or the cloud provider. A quick outline of the storyboard of the demonstration is that I'm basically going to take a photo album web scale application, deploy it onto a cloud testbed that's based in Berlin, in the Technical University of Berlin, that is operating OpenStack, and then execute the application and place it under some workload, and then we're going to explore the energy consumption of that application as the workload changes. So the flow of the demonstration is in the right hand side. So we have several components that interact within our architecture to deploy an application with energy awareness in mind. The first is the application manager, which is the input in, or the starting point in this demonstration, that basically assesses the needs of an application and tries to find a suitable provider. This isn't something that I'll show in the demonstration, but it's in any depth, but it's a capability that we have in the toolkit. So the idea here is that eventually we'll be able to select energy efficient, the best energy efficient provider for a given application's description or characteristics. So once we have sort of orchestrated the application, we deploy it via the virtual machine manager component that we have here in 4, which is an interoperability layer on top of standard infrastructure managers like OpenStack and OpenNebula that provides virtual machine scheduling functionalities. And I'll show you a bit more about the energy awareness that we've built into the virtual machine manager's scheduling functionality within the demo. Once the application is deployed, we have some monitoring infrastructure tools that we use to then explore the energy consumption of that application. So some of the achievements that we have managed in the first year of the ASCETiC project regarding static energy awareness is in that we've been able to predict the energy consumption of virtual machines and use that information as a way to schedule resources in OpenStack, i.e. guide its deployment of virtual machines to physical host machines. So here, if we took an example, if you had a heterogeneous data center with lots of different generations of hardware, the virtual machine manager can take those characteristics and assign a virtual machine, given its workload, to a specific node that basically minimizes its energy consumption. And we've also, in the first year, have some real-time collection and analytics tools. And finally, just before I start the demonstration, the application that we're using to showcase the ASCETiC architecture is an enterprise application based on JBoss. It's a cloud scale application that's comprised of 3 tiers: a MySQL backend instance, multiple JBoss web container instances that are load balanced by HA proxy. And in the demonstration, I'll load this system up with 1,000 emulated users via JMeter. So onto the demonstration itself. Because when we're entering the system at the pass layer, there isn't actually any user interface here. So what I'm going to show you are basically a scripted deployment of the application, and then the tools that we have available that enable you to explore the energy consumption of that application. So in the top part of the screen here, I'll run a deployment script that basically takes an OVF description of an application and deploys it to OpenStack. And what we'll see is that this part of the screen will show the life cycle of that application. So we can see here that that we've negotiated with our infrastructure providers to see whether or not they will accept our application. We're contextualizing the application, i.e. orchestrating the different elements so that it can be deployed onto the specific provider. And then we're basically uploading the images to OpenStack at this point in time. This takes a few minutes. So with that in mind, I'll introduce you to the Virtual Machine Manager component, where we see the most novelty in the first year. Already in the dashboard of the Virtual Machine Manager, if I just refresh it, we have some ability to ascertain the energy consumption of the cluster as a whole. So the cluster that I'm using for this demonstration, it comprises of 4 nodes. 2 of them are used for compute. 1 is used for the head node of OpenStack, and the final one is a data node. And we can see already that we have some ability to monitor the energy consumption of these nodes and the usage of them. If we look at the Virtual Machine Manager's list of virtual machines, we can start to see that the different virtual machine components of this 3-tier web application are coming online, and we can see that the Virtual Machine Manager is assigning these machines to specific hosts. So in this instance, ASOC 9 has been chosen by the Virtual Machine Manager to deploy the 3-tier web application. If we click on the ASOC 9 link, we can see already the ASCETiC toolkit can provide you with traces of the power consumption of a specific host. So we can see as these virtual machines are being deployed that the booting up process is using resources and has an associated power consumption with that. What's that, sorry? So sorry, yeah, I explained the graphs. So the red here is the power consumption with the y-axis in watts on the left-hand side, and on the right-hand side is the load of the system, which is green, the block green in this. So we can see that at idle, this machine uses about 330 watts of power, and when we deploy some virtual machines, it's jumped up to about 380 watts. And that's not the application starting themselves, that's just the boot up process. So eventually we'll see that this graph plateaus back off, and we get back to a steady state, and then we'll invoke the load to explore what happens when we add users, synthetic users to the system. So that's just one of the hosts. So there are other hosts. We can see ASOC 10, which runs the OpenStack head node or front end and dashboard, etc., and all the other parts of the OpenStack infrastructure. It's quite erratic. So you can see from here that there's a lot going on the head node, which would suggest that there's maybe potential improvements to be made in OpenStack regarding the efficiency of the software when nothing's actually happening. That's one conclusion you might be able to take away from that. And then ASOC 11 is not being used in this deployment, and then ASOC 12 is our data node, and we're not really doing anything data intensive, so it's flatlining as well. So if we go back to the decision making that the virtual machine manager has made to deploy our virtual machine to a physical host, we have an energy modeler in the infrastructure layer that tries to predict the energy consumption of a virtual machine given its resource requirements described in an OVF template. And we can see here that the reason why the virtual machines were deployed to the ASOC 9 node was because they were predicted to use less energy. And the reason behind this is that the energy awareness, the scheduling algorithm that we've implemented so far tries to consolidate the use of machines, so that if we can have more virtual machines running on one box, that's better, because the baseline energy consumption of a host machine is quite a lot. So the difference between idle and load is quite small compared to idle in the infrastructure that we have. I'm not saying that could be the case for every server out there, but that's what we've found. So we can see that the energy awareness has placed that energy aware algorithm has placed that these virtual machines on that nodes. We also have a number of other scheduling algorithms that we can play with. So as part of this project, we're going to look at trading off the performance, cost, and energy consumption of an application. So we've been working towards cost-aware scheduling algorithms and other algorithms that are related to the performance trade-offs. And hopefully we can come out with some algorithm that can take all these different criteria into account when we do the scheduling. So just to prove that the virtual machines are running on the OpenStack infrastructure, if I refresh the dashboard, you can see that we have the 5 virtual machines for this application. We have the MySQL backend, the proxy, the load balancer with 2 backend web nodes. If we go to Zabbix, our monitoring infrastructure tool that we're using as part of the architecture, and we go to the graphs, not only do we have the ability in ASCETiC to look at the energy consumption of a host machine, but we have a model in place that will translate the energy consumption of a host machine and attribute that to the virtual machines that are running. So if I take the ID of a virtual machine that will be loading up in a few minutes, so here I've got an ID. Just put that there, so it's easy for me to find. We have a very similar graph here, but just for the virtual machines. So in this we have again power consumption of the virtual machine in red, that's the red line, and in the block color here is the CPU time. So but in the previous graph it was just the load average. Here we're looking at comparing the power consumption to the system user I/O CPU time. So just to prove that the application is running, we can have a look at the load balancer. So we can see that the JBoss application, which is running on this URL, is up and running and is being served by this proxy, HA proxy load balancer. And at the moment, the takeaway message here is that there are no sessions active. If I go back to the top of the screen and invoke the JMeter stress test, which basically emulates users hitting the load balancer, what we'll see is that the number of sessions increases in the load balancer. So we can see already that there's 282 concurrent sessions hitting the machine, and this will reach a peak of about 1,000 over a minute or so. And that this has an effect on the energy that we attribute to the virtual machines themselves. So you can see that after the virtual machine booted, there was some resource activity, there was an idle time, and I've just invoked the load. That we're seeing that the virtual machine idle is being attributed about 40 watts of energy, of power rather, and I've just moved the time series graph along by mistake. And at load, it's using about 75 watts of energy, and that the CPU time of this machine is also spiking because of the induced load that we've put on the system. If we go back to the host machine itself, that we assigned the virtual machine to, so ASCETiC 9, we can see that there's also been an associated peak in energy consumption of this specific node due to the associated CPU load of the system. So that sort of brings me to the end of the demonstration. Are there any questions?
Have you measured the load of the administrative manager for load management?
So yeah, that's an interesting question that we get asked quite a lot. Is what's the energy consumption of the ASCETiC toolkit that you're using to manage the energy consumption of your application? And at the moment, we've looked at the energy consumption. We haven't attached a number to it, and at the moment, it's reasonable. So the one thing that this demo highlights is that the frequency of the monitoring interval that you poll the metering devices and measure the energy consumption of the virtual machines has an impact on the energy consumption of the system that is trying to do that monitoring. Yeah. So
because you could end up consuming more in the manager than what you say in the application.
Yeah. So in our instance, I'm polling every second so that you can see something interesting happening on this graph. If you look at monitoring solutions that are used at enterprise levels, like at Google, they monitor things on a 5-minute interval, and they don't really care too much about the fine granularity. But if we were sat here for like an hour trying to watch a graph, it won't be too interesting. So
you've demonstrated this in the context of OpenStack.
Yes.
With other cloud packages.
So from an interoperability perspective, we have HP who have a keen interest in OpenStack. So although our architecture is interoperable, we don't actually have a plan at the moment to use OpenNebula or other competing solutions, which is, in my personal opinion, is something that I'd like to explore, because Leeds have historically grown into the cloud computing research area through learning about OpenNebula. And now that we've started to use OpenStack, we're drawing a lot of parallels between the two, and we're finding that there's a lot of stability issues and usability issues with OpenStack that we're not finding in OpenNebula. But that may change over time. But
even more generally,
yeah.
Portable is you conceive of making it possible to install on an arbitrary framework like an Amazon framework?
Yes, yeah, that's one thing that we definitely do want to look into. So here, all our infrastructure is backed by meters at the wall. So each server that we have in our cloud is measured. But in Amazon, they're not going to provide you that functionality. So the idea here is that we're going to develop models to enable you to estimate the energy consumption of virtual resources that, say, Amazon or Microsoft provide you.
In fact, that was in my mind when you were talking about the monitoring issue, is that if you could develop a model that you check periodically to make sure that you haven't gone wildly off track, but essentially simulate what you think the energy consumption should be under those conditions. Just extract the information that's allowed to keep your simulation on track, and then periodically
try and sort of learn. Yeah. This is just like one aspect as well of our architecture, in that We want to spend a lot of time on the software development aspects of cloud applications, which is at the moment something that people don't really consider as a place where you can reduce the energy consumption of your infrastructure as a whole. So the idea is that basically you can do more with less, get more performance out of your application, and therefore have a lower energy footprint.
Any other questions? Thanks very much.
Thank you.